In this video, I am going to show you how to derive these four one-dimensional kinematic equations. Let us start with the definitions of average velocity and average acceleration. Average velocity of an object is v bar is equal to delta x divided by delta t. And the average acceleration of the object is a bar is equal to delta v divided by delta t, where delta x is the displacement of the object in a time interval delta t, and delta v is the change in velocity of the object in the time interval delta t. We derive the kinematic equations with the assumption that the acceleration of the object is constant. When the acceleration is constant, the average acceleration over a time interval is equal to the instantaneous acceleration at any moment within the time interval. So we can replace this a bar with a, and we get a is equal to delta v divided by delta t. We will use these two equations. So take these equations. Next, we do some changes in the notations. We take the initial time t1 is equal to 0 and the final time t2 is equal to t. So the time interval delta t is equal to t2 minus t1 is equal to t2 is t minus t1 is 0. So delta t is equal to t. And we take the initial velocity v1 is equal to v0 and the final velocity v2 is equal to v. So the change in velocity delta v is equal to v2 minus v1 is equal to v2 is v minus v1 is v0. Next, we substitute t for delta t also here and substitute v minus v0 for delta v. Now take this equation, multiply t both sides, you get at is equal to v minus v0. Now solve for v, you get v is equal to v0 plus at. This is the first kinematic equation. Now take this equation. From this equation, you can write delta x is equal to v bar times t. We have two velocities, the initial velocity which is v0 and the final velocity v. Add these two velocities v0 plus v. Now divide by 2. This is equal to the average of the two velocities. Now substitute this for v bar. So this is equal to this times t. This you can write as 1 over 2 times v0 plus v times t. On the left hand side, there is delta x. This is the second kinematic equation. Next, take this equation, delta x is equal to 1 over 2 v0 plus, for v substitute this, V0 plus AT times there is a T is equal to 1 over 2 V0 plus V0 is 2V0 plus AT times T is equal to 1 over 2 multiply this and T you get 2V0 T plus multiply this and T you get AT squared. This is equal to, now divide this by 2, you get V0 T plus 1 over 2 AT squared. On the left hand side, there is delta x. This is the third kinematic equation. Next, take this equation, subtract V0, you get V minus V0 is equal to AT. Now divide A both sides, you get this is equal to the time T. Now take this equation, delta x is equal to 1 over 2 V0 plus V. For T, substitute this. Next, multiply 2A both sides. You get 2A delta x is equal to, write this first, plus V0 times this V minus V0 is equal to, now by using this formula, you can write this as V squared minus V0 squared. At the left hand side, you have 2A delta x. Now solve for V squared. You get V squared is equal to V0 squared plus 2A delta x. This is the fourth kinematic equation. So all the four equations are derived.